All right, welcome and thanks for joining. Moving into chapter 5 now. In chapter 5, we're still going to be working on trig, but we look at it from a sort of different perspective. So in this chapter, what we're going to be talking about is analytic trigonometry. And basically what that means is that we're going to be working with general trig equations of any angle, as opposed to when we're talking about using the unit circle or when we're talking about doing right triangle trig. Now we're talking about, well, what is it that's true regardless of the angle? So there's a lot of stuff that we covered in chapter 4 that I'm just going to sort of breeze over. I would recommend, pause if you need to rewrite these down. But we have 6 reciprocal identities. That would be that cosecant theta is equal to 1 over sine, secant theta is equal to 1 over cosine, cotangent theta is equal to 1 over tangent. Sine theta is the same as 1 over cosecant, cosine theta is 1 over secant, and tangent theta is equal to 1 over cotangent theta. All that gives me is different ways of rewriting those 6 trig functions. But those aren't the only ways that I could rewrite some of those. For instance, we also talked about the 2 quotient identities, which gives us 2 other ways to rewrite tangent and cotangent, because tangent can be written as sine over cosine, and cotangent could be written as cosine over sine. This again was in section 4.3. If you wanted to go back, see, it's just the same thing, but we did really cover it. And then also the Pythagorean identities. Pythagorean identities were those 3 that sort of dealt with the idea of squared. So I have sine squared plus cosine squared equals 1, tangent squared plus 1 equals secant squared, and 1 plus cotangent squared equals cosecant squared. And the way to sort of look at this is that the cos stay together. When I'm saying that, what I'm saying is sometimes people mix up and put like 1 plus tangent squared equals cosecant squared, but it's the cotangent with the cosecant, and then the tangent with the secant. Most people, or everybody, remembers this one. Sine squared plus cosine squared equals 1. That's the one that you're going to use the most frequently. So all of those 6, 7, 8, 11. All of those 11 identities are ones that you've already looked at. We didn't do much with them on the homework or anything like that. We just had a couple problems. But this is like what the first half of this chapter is really going to look at. But we add more of them. So what we also have is cofunction identities. Now, cofunction identities, you guys have seen this before. In a lot of your homework assignments, it has said like, oh, what is the cosine of 90 minus theta? And some of you hopefully realized that that is the same as just the sine of theta. In geometry, last year you studied this with just different notation. You said that cosine of angle B is the same as sine of angle A. That's exactly what this is saying, because B, if we were talking about a right triangle, B was always 90 minus whatever angle A was. So that's what all of these are just saying. The sine of 90 or pi halves minus theta is cosine theta. The cosine of pi halves minus theta is sine theta. The tangent of pi halves minus theta is cotangent. The cotangent of pi halves minus theta is tangent. The secant of pi halves minus theta is cosecant. And the cosecant of pi halves minus theta is secant. And you can notice these sort of always pair off. Sine and cosine, cosine and sine. Tangent and cotangent, cotangent and tangent. Secant and cosecant, cosecant and secant. So that's 6 more identities for you to make sure that you have memorized. You will use them a lot in the homework. These ones, not as much, but you'll see them. Then we also have even and odd. Now, even and odd, you're thinking like, okay, technically this is 6 things to memorize, but you could really just memorize 1, and that is like, just memorize cosine. So cosine and secant by default, since it's a cosine function, is an even function. And what that means is if I take the cosine of a negative angle, I get the same as just the cosine of the positive angle. And if you're thinking about that, if I said what is the cosine of pi thirds up here versus the cosine of negative pi thirds down here, because cosine is the x values, this is going to be the same x value regardless. That doesn't happen with an odd function like sine, cosecant, tangent, or cotangent. So this odd and odd. The reason it doesn't happen, and I'll just draw this once to explain what odd looks like. the sine of an angle. So again, if we said pi thirds versus negative pi thirds, the sine here is root 3 over 2. That is not going to be the same as the y value down here. The y value will just be the negative of that. So negative root 3 over 2. As where here, this was 1/2 and 1/2. Even, it didn't matter if I took a positive or negative angle, I get the same answer. Odd, if I take a positive or a negative answer, I just get the negative result from the positive angle. So again, that's 6 things. If you just remember that cosine is the even one, that would tell me that secant is also the even one, since it's a cosine function. And then all the rest of them are odd. Right, that's all I'm covering in these notes. Everything else that we're going to go through is just going to be some examples. So go to that examples video, watch, see, especially some of these verification questions. Those are really good and really tough questions at times. Those are the ones that are sort of like a puzzle, as I said in 4.3. Otherwise, that's it for the notes. Feel free to jot down, see if you have questions. Most of it is just memorizing some identities, or all of it is just memorizing identities and being familiar using them.